Welcome to Sigest, your fortnightly serving of digestible science from plant and food research.
Kia ora koutou. Welcome to another episode of Sigest. I'm your host, Tom Moore, and today we have senior scientist Dion Mundy talking about the new developments in vine health over the last 5 years, including artificial intelligence. Dion, welcome to the show.
Hello, it's great to be here.
It's great to have you on board again. Dion has given a Science Life for Me around 5 years ago, so a lot has happened in that time, and we're excited to introduce Dion as well to the Sigest podcast family as an interviewer in upcoming episodes. So Dion, for the listeners that haven't listened to the last podcast, can you please give a brief idea about what you do at Plant and Food Research?
Basically, I work predominantly on grapes, but also on some other horticultural crops, and it's my job to keep them healthy. Sometimes called a plant doctor. My surgery tends to be with a chainsaw with woody plants, cut them open, see why they died, that sort of thing. It's not as finessed as a real doctor, but all the work that I'm involved in is about having better, more sustainable systems that continue to support New Zealand's horticultural exports and our domestic supply. So it's about healthy plants that produce food.
Great. And you started in Canterbury.
Yes, I grew up in Canterbury. I actually grew up on a vineyard and a winery, and my parents were involved in vegetables before that, so I've literally grown up with horticulture. When I finished university, I wasn't prepared to go into the family business, so now I work for the whole industry across New Zealand, and I've had the privilege of travelling overseas to see how well we compare and what ideas and things we can bring back to New Zealand.
Cool. And have you travelled recently within the last 5 years?
I went to Bordeaux and to Germany just before COVID broke out. I was coming back through Singapore, watching all these people coming off the cruise ships that had been cancelled and going, yep, now's a good time to be back in New Zealand. And I haven't been away since.
Okay. So we're recording this from the Lincoln site. What brings you down to Lincoln?
I'm actually managed from Lincoln. This is where the rest of my team and the rest of my group is. I get down here quite often, at least 3 or 4 times a year. I also do a lot of work over in Michuaka, and in the past I've done quite a bit of work up in Hawke's Bay as well.
Mm-hmm. What are some of the up-and-coming tools in the viticulture space?
Right, so in viticulture, one of the things that we have is if we've got nearly 40,000 hectares of grapes, we don't want to be walking up and down every row of grapes to see are they healthy or not. Even if you have quite a rare event, maybe 1 or 2% of the vines that may be suffering, if you've got 2,000 vines per hectare, the numbers get really big really quickly. So part of what we've been doing is taking the past work where we've looked for trunk disease symptoms, mapped them manually, followed them year after year, and now we're starting to apply some more advanced techniques. We have a collaboration with France, that's why I was in Bordeaux, and we've had a PhD student from Bordeaux, Malo, come and work with us. He's a computer scientist, so we took images of all the vines, up and down rows of grapes. I provided the biology and sorted 10,000 images into which ones had which symptoms, and then he did all the AI work to develop a way of identifying those symptoms and applying those algorithms to new pictures. So basically the computer can say, yes, that has disease or that doesn't, in the same way that I don't have to walk up and down the rows all the time.
Mm-hmm. Could you give a bit more about the disease? Like, how does the disease manifest itself?
Yep. So trunk disease is a fatal group of fungal pathogens. So the grapevine grows when we prune it and make wounds up in the head, up in the top of the vine. Those wounds can get infected during the winter. The fungus moves down and it slowly takes over the woody part of the plant, blocking it off. And basically the pipes are blocked, the water can't get to the leaves, the vine eventually dies. It's slow, and sometimes you don't see symptoms for maybe 5 or 6 years. So it creeps up. And what we're looking for when we visually go through a vineyard, we look to see, are there vines that look like they're partially blocked, that some of the leaves aren't right or one side of the vine isn't growing, those sort of visual symptoms. Mm-hmm. And that's non-destructive. The alternate is to get out with the chainsaw and chop them off and have a look and see if there's staining, or you can see visible signs of the fungi inside the vine where it's slowly taking over and killing the vine. Obviously that takes them out of production. You don't want to just go through and cut a couple of hundred vines off for the fun of it. But growers use a combination of both. They might monitor the external symptoms, the visual symptoms, and if they're starting to see disease in the block, they may go in with the chainsaw and cut some vines to confirm just how much disease there is. And they have ways of managing the vines. We can rework the vines. Grapevines are quite resilient. If you get below the disease, treat it like a cancer. You cut it out, remove that canker or that cancer of the vine, and you've got healthy tissue, the vine will regrow, and you can be back in production in 18 months.
The way the disease spreads, is it likely that you might find clumps of disease?
Yes. So the disease itself, fungal spores, are either rain splashed, in which case if you've got dead wood with the fungi producing the spores on it, then the wood around it gets infected when it rains and those spores splash. Or some of them are actually fired out under pressure from the fruiting body, and those spores can float in the air after rain for up to 36 hours. So until now, the only thing that we could do was pre-wound protection. And so if you have a new wound, you protect it with a chemical or a physical barrier. It stops the spores getting in. But you can imagine if you're making 6, 8, 10 cuts per vine, more than 2,000 vines per hectare, you literally have death by 1,000 cuts, because eventually you miss some of those wounds, they get infected and the vine starts to die back. And you can't make great wine from a dead vine.
And this is where the artificial intelligence comes in. So is the artificial intelligence coming along and going, is there disease, yes or no? Or is it grading into an index of severity like 1 to 10?
What we're actually trying to do is take the symptoms. We know that individual symptoms have different probabilities that vine will die. From our physical walking up and down rows and sampling a proportion of the block, we have a model that will tell us what is the likelihood of that vine dying. And we're trying to apply that to whole blocks, not just samples. So we can actually, okay, we've got all these symptoms. These symptoms mean that vine is more or less likely to die. Let's plot that, and can we plot that over time and see what the progress through a whole block is? Have we got a hot spot that we need to go in and treat? Or is our management working really well? And in fact, we've got very little disease in there and it's stayed low for a number of years. There's that affirmation that we've done a good job and we need to keep doing that.
Excellent. For the data scientists out there, what is the actual techniques that you're using? Like, is it a machine learning model? I know that's quite vague. Or is it like a neural network? Or what is the more detail of the intricacies of the modeling?
I'm not a data scientist. That's why we had the Melo as a PhD student. I know he actually tried a number of different techniques and compared them. One of the problems is the number of images that you capture, how fast can you process those, how much of the data do you need to make good predictions, can you fill in where you've got edges and you're not quite sure. For a grower, you'd rather have a false positive and manage it than a false negative and have the disease get out of the way. So taking the model and actually turning it into a useful system is that next step that we're working on now. Mm-hmm. So the PhD student found out what the optimized way of detection was. Our next step is to take that and then turn that into something that's useful to the grower rather than just an academic exercise.
Mm-hmm. That sounds great. It sounds like quite a useful technique that could be applied to other systems.
Yes.
But is it that it's really good for your system because you have a database of 1,000, 10,000 photographs that you can bring upon to train the model? This analysis, the way of working, can it be brought across to another system?
It should be able to be. So that grapes are quite nice in that they are upright, easy to photograph from the side, but our new FOPS apple trees are the same. And so there's nothing to stop us from doing a similar thing where we'd capture images and be able to identify.
When you say capture images, is it a person going along taking photographs, or do you have an automated machine that does it?
So we have a piece of equipment currently that we've used for research that was actually developed by the Bordeaux group. It has a camera and a high-powered flash. It runs off a car battery. We can put it on a little truck that goes down the row of grapes, and we can drive along, and the high-powered flash lets us take a photo with no shadow, even in the middle of the day or at night. I've managed to do it at night as well. And that lets us get an image that we can process. But there are also commercial companies out there that have imaging methods that are already scanning vineyards for other things. And so there's an opportunity that if they're already scanning the vineyard 8, 9, 10 times a season, and each vine is GPS, we may be able to add our algorithm when we're looking for trunk disease at key times to the data they're already collecting.
So how long have you been doing this for, taking photographs and assessing them?
The photographs is the last 3 years. Before that, we have, as I said, we did visual, walking up and down rows, marking where the vines were. We were starting to GPS vines because it's very easy over a 10-year period to walk up and down different rows of grapes and go, oh, we've got the walking dead. There's a zombie here. The dead vine was in that bay last time, and this time it's in this bay. You know, was a one out, and going along and putting labels on posts so that you've got reference points and things like that. So as the technologies become available where we can easily identify individual vines with GPS, we've been doing that, and I'm starting to learn to use ArcGPS Pro to be able to actually map my vines as well. And for me as a biologist, the big thing is to watch over time. How are things spreading? Is it a point and it's spread out from that, or is it more random? Am I seeing an infection that happened 7 years ago and it's just starting to express now?
Yeah, it's fantastic that you've got a longer term data set of at least 3 years to be able to sort of see changes over time.
At the moment, I've got some vines I've done a couple of times per season or at key times, but I actually have some data sets I've manually collected over 10 years, and that's what's allowed us to do some of the modelling.
Ah, fantastic. Over that time span of the data that's been collected, have you seen like notable changes? And I'm thinking in terms of like temperature warming and climate change. Is this a useful tool for looking at the impacts of how that affects viticulture?
In this project, because our data sets are not quite as large or as long as I'd like, we haven't done so much of that. But I've also been involved in another project, which was our Land and Water funded project for National Science Challenge. And in that project, it's been multidisciplinary. We've had modelers, biologists, commercial companies, consultants, quite a few of them. We ended up on News Hub actually the other day. We looked at mid and late season climate scenarios and what is that going to mean for the diseases that we're interested in. And for grapes, we looked at powdery mildew and botrytis because we've got good data sets for those. And in apples, we looked at fire blight. And for those two diseases in grapes, botrytis and powdery mildew, we now have an interactive tool that's on the Hort Plus website. You can go in, put in your property details, and it will give you a 5 kilometre square of around your property, and it will tell you mid-century or late century using your choice of the scenarios for climate change, what the likely risk of or increase of risk of botrytis or powdery mildew is for your site. And we've worked with the economists from Lincoln University, and it will tell you what the increased cost will be to manage that disease. And that's both on average, but also in an extreme season. So mid-century, if you had the best or the worst scenario for climate change, you can say, right, on average, it's going to cost me this much more for botrytis management to maintain my high-quality grapes for Marlborough Sauvignon Blanc. But in an extreme year, this is how high the cost could be. So you can start to put mitigation and planning in place for that.
That's a really cool tool. What is the data sort of in the background of informing such a tool? Do you have lots of experiments and like expert knowledge that comes together to try and think of these scenarios?
It's brought together 25 years of experience that I've had. It's using international full season models and then testing that data for New Zealand situations and running it through the climate change modelling. We've also tapped into the sustainable production part of Plant and Food using their staff that have been modelling the suitability of sites. And there are some sites where the disease risk goes down in the future because they're no longer suitable for growing grapes. In those climate change scenarios, you won't have disease because you won't be able to grow grapes there. In some of those scenarios also you'll have more disease in Southland because you will be able to grow grapes in Southland now. It's not currently viable, but in the future it will be. And as soon as you can, you'll have powdery mildew disease pressure that goes with that. But again, it allows people to make informed decisions. If I'm going to do this, if my family's investing in this bit of land in the future, or if we're a corporate and we're looking at doing this, this is what we've got to budget if we're going to do this because of the disease pressure.
So the forecast horizon for this ecological forecast, I suppose, is mid-century. Can it also do shorter term predictions as well? And do you update it with new data as it comes through, new knowledge that comes in?
So the current project simply has historic data and the financial cost, current, mid and late, but the platform has been designed that we could put other diseases in and that we can put other crops in. So it's more a platform for using in that way. Some other work that I've been doing with some other modelers, we've been looking at season-long forecasts, but that's still a wee way off. We've got some work to do with that, but what we did was we took an existing model, we applied it to New Zealand data because it had come from the Mediterranean and they have slightly different climate, and we've looked at historic New Zealand data and tweaked that model to be able to do some season-long predictions. But so at the moment, we can tell you there's disease models out there that if you have this weather at the moment, we can tell you what the disease is going to be like. And we now have a tool that will tell you mid and late century, but we don't have something that says at the start of this season, given a range of seasonal predictions, what might be the extremes. But that's the bit that we're working on.
I'm quite interested in how you accommodate 3 different types of diseases. Would you be able to sort of go into a bit more detail around what are the differences between the 3 diseases you described, and then like how that would implement in the model?
So that they are separate models using the same. So botrytis is a saprophyte and an ecotroph. So
I'm sorry, what was that?
Yeah, I was waiting for that one. A saprophyte, so that means it lives on dead tissue and just colonises it, and a necrotroph where it actually kills tissue around it, necrotic. So botrytis has a whole bunch of enzymes that lets it take over dead cells and use them for food, but it also can secrete enzymes to kill cells around it so that it's got more food basically and it can colonise them. That's totally different to powdery mildew. Powdery mildew is an obligate pathogen. It can only live on live, healthy green tissue, and it just sucks the goodness out as it needs it. So we had to have totally different models for them, and they have different weather conditions. So we needed to extract different parts of the weather modelling for the climate change, enabling us to model them. But we have this platform that we can plug those in. And so they're both fungal diseases, and the fire blight, the apple one, is a bacterial disease. It affects flowers and is a very tight time frame when it can get into the flowers. And it therefore affects fruit because if it kills flowers, but it can also get in and kill the wood and hence damage the tree. So we chose those 3 exemplars because they sort of cover the major things that we have. Diseases that come in and kill things, diseases that live in their host and suck the goodness out, both from the fungal side, and then a bacterial disease as well. So there's scope to then expand those with that knowledge. It'd be really nice to do some root diseases, but they tend to be a bit harder because they're below ground and modelling. You need an existing model to then apply it into the system. And so you also need to have economics of what's the costing of that to then do And we had the data for those 3 diseases, so they're the ones we picked. It's low-lying fruit, low-hanging fruit, I suppose.
What are the links between the optical recognition project and the project you just described? So does the model you just described take into account like dispersal? So if you know that it's more likely to have this disease in this area, it will expand out, and then in 2050?
No, all of the climate change modelling ones that we did were what I call seasonal diseases. So you start the season from fresh. You probably have, if you had bad powdery mildew last year, you're probably under a little bit more pressure, but they're just what is the seasonal risk, and it resets. Where the type of modelling for the trunk disease is quite different, and it's going to require a whole lot of spatial statistics that I'm looking for a good statistician, because that's not my forte, and I'm just learning the tools to be able to plot those out. And I suppose that's a big thing about all the research that I've been doing, particularly in the last 5 years, lots of collaboration. It's not just 4 pathologists in a room doing something. We're multidisciplinary, often multi-organisation, working with the universities, working with commercial companies, bringing everyone's skills together to get a really good outcome for the industry and for New Zealand.
Is there anything else in the development world that you'd like to share?
Certainly. Last week I was actually out in an apple orchard, because I do get out of grapes occasionally, in the pouring rain doing a rain splash experiment, which might sound really simple, but one of the problems we have is replicating field experiments. And this was in the FOPs, the Future Orchard Systems apples. They look a bit like tall grapevines. They're quite planar. You look at them and you can see through them. They've got uprights. It's really easy to see where everything is. So what we did was, we can't see spores in the field, and we're using a fluorescent dye that you can see with a black light. So we put a little packet of the fluorescent dye out on one of the stems of the apple tree, and then we put a whole lot of spurs around it to capture the splash dye. Now, in the traditional system, you'd have to find the spurs on the apple tree, because that's the bit that the fruit's on. And they're all different, and they're all in different places. So what we did was we actually got some very clever people in plant and food to design and 3D print biodegradable plastic spurs. And then we put them up in a grid in each tree around the dye packet, so that there's exactly the same distance between each spur, up and down and across. And we put some rain gauges underneath, and we collected the spurs back after we've had our rainfall, and we looked to see under the black light how many spurs and which spurs, because we knew each position of each spur had fluorescence on them. So we know the raindrop fell, hit the packet of dye and splashed out, in the same way that a spore would splash with a raindrop landing on a fruiting body and splashing it. And we replicated that a number of times. I think we've done it 4 times now on 3 trees with 25 spurs per tree. And as you might have guessed, we can't always make it rain. So we've also set up some artificial irrigation overneath the top. And we've now done artificial rain and real rain, and we can show that we get a similar amount of water in the rain gauges. We're getting similar results of splashing onto the spurs. So we've done a good job of making some artificial rain. And so that's a really new project. I didn't think 5 years ago I'd be using 3D printing in the field or fluorescent dyes, but it's taking things that exist already and applying them to a new question, new situation. And the other really big thing that we're doing at the moment is we've just had a PhD student at Lincoln University complete his project on trunk disease, and he looked at the communities within the vine and which other organisms in the vine might actually be helping inoculate or keep that vine healthy. It's called disease escape. So when you've got a really sick vineyard and there's this 2 or 3 vines that just remain healthy regardless, he found significant differences in what was inside those vines compared to the unhealthy vines. And these are the other microorganisms as a community that make up the microbiome. And so we're continuing some of the work out of his PhD. Can we take that information and apply it to the industry to make a more resilient grapevine. And it's the great thing about working with students, and we do quite a bit of that. They get to go out into industry and we introduce them to people, we introduce them to existing programs of work that we have, but we also learn so much. They bring new skills, new ideas, lots of energy and enthusiasm, and we can bring that. We grow as researchers as well by hosting them and being involved in their projects. So I really enjoy that.
Cool. And has that been a passion of yours for quite a while?
It's always great to have new people come and challenge, ask you questions. Why do you do that? What's the great about that? Particularly working with Melo as a computer scientist, he had a whole lot of questions about the biology. And a lot of times we went, we don't know. We still don't know. We just know if we do this, this is what we expect to see.
It sounds like some of these PhD students will bring in new ideas.
Yes.
Just a very fruitful way to bring in like these different tools that you have in other disciplines and bring them across.
Yeah.
Actually, these technologies that you described seem like quite recent developments. And
yeah, it is. It's great. I always said that I'd only be in the job if it wasn't boring, and 25 years later, it's definitely not boring. And I really enjoy the science and the interactions with the range of people that we work with. It's nothing more satisfying than being called in by a grower and being able to walk through and often just confirm what they were already thinking. Yep, that's good practice, or no, there's a bit of a problem there. Let's see, these are the options you have. Which one's going to fit your farming system?
Cool. Thank you so much. You seem to be an absolute natural when it comes to podcasting, and we're looking forward to having you on the SciGest podcast in the future. What sort of brought you to wanting to become a podcaster?
I've always enjoyed communicating our science and also finding out about other people's science as well. I do some teaching at NMIT as well, at Nelson Marlborough Institute of Technology, and it's always great when you're involved with students who, again, challenge your thinking and why we do things, but also seeing that light bulb moment when someone realises, that's why I do something, or something that I do, it has real significance. And I think podcasting is part of a way for us to interact with more people, to tell our science stories, and get some of that great science out there where people can interact with it.
And having you there at the Marlborough site would be fantastic to tap into all those stories and bring them to the world.
Looking forward to it.
Cool. It's been fantastic talking to you today and hearing about the developments over the last 5 years of AI. And personally, I found this super interesting as a statistical scientist to learn like how some of these modern tools are being brought into viticulture. So thank you for sharing. And thank you out there for listening. If you want to hear more of our podcasts, please check out our SciGest podcast page or subscribe to our channel in iTunes or your favourite podcast provider. And don't forget to post a review and rate this podcast. Mā te wā, and farewell until next time.